We're to decide if each statement is true or false for the polynomial pictured in the graph. So the first statement is the function has 4 extrema. We know extrema is the word for minimum and maximum, and it's a plural word. So as I look at the graph, here is a minimum. It is a relative minimum because the graph goes lower. Here is a relative maximum, another relative minimum, and another relative maximum. All are relative because the graph does go to both positive and negative infinity. But if I count them up, 1, 2, 3, 4, the function has 4 extrema. That is true. Next, it says the function has an odd degree. So the one way that I can tell that, and there are a couple ways, but as I look at the left side of the graph, it's headed towards positive infinity. The right side of the graph is headed towards negative infinity. And so the two ends of the graph are going opposite directions. That is true for an odd degree. So this is true. Letter C, the function has a negative leading coefficient. Well, this depends on the right side of the graph. So if I look at the right side of the graph is headed towards negative infinity. So that is true. Letter D, the function has 3 solutions. Well, as I look at the graph, here is a 0, which is the solution. There is another one, and here is a third one. So at first glance, this appears true, but I'm going to circle back to it after I look at the last one. It says the function has degree of at least 5. I know that the degree is the extrema plus 1. I look at my extrema, which is part A. So in this one, it'd be 4 plus 1, which equals 5. And I know that the degree needs to be at least 5 because there might be a complex or imaginary solutions that I'm not seeing on the graph and that don't show up as extrema. So that's why there's the at least in there. And so this is definitely true. Circling back to letter D then, it has 3 solutions. This is false. And I know that because the number of solutions must equal the degree. And we said that the degree has to be at least 5, so there has to be at least 5 solutions. But how do I reconcile this with what I saw on the graph? Well, on the graph, I saw 3 real solutions. And since the degree has to be at least 5, I know that there has to be at least 2 complex or imaginary solutions to get a minimum of 5 total. All right, so let's take a look at another one. So example 2. I would love for you to pause the video, answer these on your own, and then continue the video and check your work. So I'm going to go through the answers and you can check your work. When I look at the graph, I know that it would continue down forever. So polynomials always go towards either positive or negative infinity. The first statement says the function has 3 extrema. So I see an absolute maximum, a relative minimum, and a relative maximum. So I see 3 clear extremes. That is true. The function has an odd degree is the next statement. As I look to the left of the graph, it is going to negative infinity. As I look to the right of the graph, it is going to negative infinity. Both ends are headed the same direction. So that is not odd, that is even degree. So this is a false statement. Letter C, the function has a negative leading coefficient. Well, this depends where the right side of the graph is headed. When I look at the right side of the graph, it is headed towards negative infinity. So that means a negative coefficient. That is true. Letter D, the function has 4 solutions. Well, when I look at the graph, I see 1, 2, 3, 4 zeros. All of them real. And when I look at the extrema, if I take the extrema plus 1, That gives me 4. And I saw 4 solutions on the graph, so I'm going to say this is true. And then letter E, the function has degree of at least 4. I'm also going to say that is true because the degree is the extrema plus 1, and the degree equals the solution, and so we have these two equal. We have it work out with the extrema. And then this confirms for me letter B, because the degree of 4 is an even number, so the function having an odd degree is definitely a false statement. We're going to move to example 3. And again with this, I would love for you to pause the video and try these on your own, and then come back and check your work. So part A, the function has 5 extrema, so I'm going to count 1, 2, 3, 4, 5. I count 5. That looks to be true. Letter B, the function has an even degree. I look at the two ends. This goes to positive infinity. This also goes to positive infinity. So since they match, that is a true statement. Letter C, the function has a negative leading coefficient. I look at the right side of the graph. It is going to positive infinity, so that means it has a positive coefficient. So this is false. Letter D, the function has 6 solutions. So looking at the graph, I see a 0 every time that it crosses the x-axis. So that's 3, 4, 5, 6. I see 6 solutions, so it seems true, but I have to check the degree first. So the degree equals extrema plus 1. So 5 plus 1 equals 6. So letter E is true. And then the solutions equal the degree. And so that is also true. So hopefully these problems helped you to see the connection, then the conclusions that we can make from a graph. Or if we had been given the polynomial itself, we could also have seen the degree and we could have guessed the extrema, etc.